Hello everyone. Welcome to Subnetting a little bit. Today we will explore elements of the subnet mask. Topics include: what is the subnet mask? What is its purpose? Why do PCs need a subnet mask? The native subnet mask. The truth table for the logical AND operation. The subnet mask is a 32-bit number. It is represented using dotted decimal notation, so it looks like an IPv4 address. But it isn't, because it cannot be assigned to a device. At the bit level, it is always a series of ones followed by a series of zeros. Here are some examples. The subnet mask divides an IPv4 address into two parts: the network portion and the host portion. It allows devices to distinguish between the two parts. A PC, for example, will perform a bitwise ANDing operation between its IP address and its subnet mask to determine its network address. We will explore the details in a later video. The ANDing operation is analogous to multiplying by 1 or 0. When a PC sends traffic, it'll perform this operation between its subnet mask and the destination address. This allows it to determine if the destination address corresponds to a device in the local network or to a device in a remote network. Here we can see how the native subnet mask maps to the address map and to the prefix length. By the way, while we refer to the classful subnet mask as the native subnet mask, others may refer to it as the default subnet mask. To determine the subnet mask, simply set the network bits to 1 and set the host bits to 0. As we know, the prefix length indicates the number of network bits. A /8 means the first 8 bits are network bits. Similarly, a /16 means the first 16 bits are network bits. And finally, a /24 means the first 24 bits are network bits. The subnet mask and the prefix length are synonymous in that they both represent the number of network bits. The native prefix length for a Class A address is /8. This means the first 8 bits represent the network portion. To get the native subnet mask, set the network bits to 1 and set the host bits to 0. Converting to decimal, we get a subnet mask of 255.0.0.0. The native prefix length for a Class B address is /16. Therefore, the first 16 bits represent the network portion. To get the native subnet mask, set the network bits to 1 and set the host bits to 0. In this case, the subnet mask is 255.255.0.0. And finally, the native prefix length for a Class C address is /24. In this case, the first 24 bits make up the network portion. To get the native subnet mask, set the network bits to 1 and set the host bits to 0. This gives us a subnet mask of 255.255.255.0. This is the truth table for the AND operation. Again, ANDing is analogous to multiplying by 1 or 0. When the ANDing operation involves a 0, the result is a 0. This means the only time the result will be a 1 is if you perform the ANDing operation between a 1 and a 1. ANDing 0 with 0 gives 0. ANDing 0 with 1 gives 0. ANDing 1 with 0 gives 0. ANDing 1 with 1 gives 1. We will explore in greater detail how a PC uses its subnet mask to extract its network address in a subsequent video. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.